Welcome everyone to this week's Science News. Today we'll talk about the Nobel Prize in Physics, yet another superconductor retraction, whether integrated information theory is pseudoscience, why antimatter doesn't antigravitate, sound that flows uphill, which I swear has nothing to do with antigravity, the world's most powerful X-ray laser, how life could come about on other planets, why we might go extinct sooner than expected, and of course, the telephone will ring. The Nobel Prize in Physics was awarded today for attosecond physics. An attosecond is a billionth of a second, or 10 to the minus 18 seconds. Just for context, that's really short. I think the Nobel Prize Committee made a really good choice here, giving the prize to Pierre Agostini, Ferenc Krauss and Anne Nullier. If you just listen to me, you might get away thinking we're pushing the frontiers in physics either by looking at very long distances or very short distances. But attosecond physics is pushing a completely different frontier, that of short times. The most common method for generating attosecond pulses is through a process called high harmonic generation. For this, you shoot the laser in some kind of cavity that contains gas, normally that's some kind of noble gas, and that creates higher harmonics of electromagnetic waves. You have to get them to overlap so that they amplify in some places and cancel out in others, and that gives rise to those very short pulses. You direct them at a sample and measure what comes out. Attosecond physics is a research area that's just a little more than 20 years old or so. It's interesting because attoseconds are the typical time span at which electrons move around in atoms or molecules. These experiments therefore tell you, for example, how long it takes for an electron to get ejected from a molecule, what the electrons actually do. And this tells you a lot about the structure of the molecule and its chemical properties. You can use this, for example, to study biological samples or to better understand how materials behave. But it's not just about observation, it's also about manipulation. You can use these attosecond pulses to make tiny currents flow in very short bursts, and that's super useful in the area of ultra-fast electronics. This research quite possibly will one day give rise to faster computers. I love it when the Nobel Prize in Physics is awarded because everyone is like, woo, physics, which is how I feel the whole year. It might even get people interested in physics for about an attosecond. A physicist who claimed to have created a room temperature superconductor earlier this year is about to have another paper retracted for academic misconduct. A superconductor is a material without electric resistance. All known superconductors either require very low temperatures or high pressure to work. If we had a material that was superconducting in an everyday environment, that'd be a really big deal because it could dramatically improve the efficiency of the entire electric grid. Today's news is not about the LK99 superconductor from the Korean group that made headlines in August, but it's a different story that we reported on in March. It's the story of Ranga Dias at the University of Rochester in the United States. He claimed that he'd produced a sample of lutetium hydride that was superconducting at room temperature, though he had to put it. Dias has somewhat of a reputation. 3 years ago, a team also led by Dias already published a paper in Nature about a supposed superconductor breakthrough. The paper was retracted last year after other scientists raised doubts about the data analysis. The story from March drew attention to another paper that had been published earlier in PRL and which now has also been retracted due to data anomalies. There are also allegations that Dias plagiarized parts of his PhD thesis. He now stands to lose a third publication. In early September, Nature put an editor's note on his paper from March, saying that the reliability of the data is in question. According to the Wall Street Journal, several of Dias' colleagues have asked Nature to retract the paper because, they say, Dias misrepresented the data. The magazine Science further reports that Dias had a lawyer send cease and desist letters to 6 colleagues who had raised accusations, warning them about potential legal consequences. The biggest issue with the paper is the graph that supposedly shows the drop of the resistivity to zero, which is the hallmark of superconductivity. This graph relied on a noise subtraction that might have subtracted a little bit too much. As several people already pointed out in March, without this noise subtraction, the neat drop of the resistivity disappears. This is all a bit embarrassing for the editors at Nature. You'd think they'd have made more effort with peer review after the previous retraction. But to me, the most amusing part of this story is that the pressure that's required to make the material superconducting has widely been reported as moderate. I find this an interesting description for 10,000 times atmospheric pressure, but then again, maybe US universities have a different notion of moderate pressure. And we have a second science drama this week. 124 scientists have signed an open letter contesting one of the currently most popular theories of consciousness, causing quite the academic rift. Their letter takes issue with integrated information theory, IIT for short, which the signatories believe has been given more attention than it deserves. According to IIT, consciousness is a property which derives from the connectivity of a system and the amount of information it can process. The theory aims at providing a way to quantify the level of consciousness. Since almost all systems process a little bit of information of some sort, IIT assigns low levels of consciousness to pretty much everything, including trees and vegetables. It's almost, but not quite, a panpsychic theory. IIT's biggest competitor is the global workspace theory, which says that the mind works kind of like a theatre with different actors on the stage and unconscious processes working behind the scenes. In their letter, the signatories condemn IIT for its panpsychistic commitments and argue that the pseudoscience label should indeed apply. The letter's a backlash to recent articles in Nature and Science about IIT that the signatories feel overstated the acceptance of the idea. But several consciousness researchers have taken issue with the letter, including Arnil Seth, who called it disappointing and clickbaity, and David Chalmers, who likened it to dropping a nuclear bomb over a regional dispute and called it unsupported by good reasoning. I side with Seth and Chalmers. You can't just declare something as pseudoscience because you don't like its panpsychistic commitment. But to me, that story was settled a decade ago when the computer scientist Scott Aronson showed that you can create a simple system with the task of solving a particular mathematical problem that, according to IIT, would have an incredibly high level of consciousness. This means that whatever the integrated information in this theory measures, it's not in any meaningful way correlated with what we mean by consciousness. So, while I don't think IIT is pseudoscience, I think it's just wrong. Hello. Hi, Rishi. Students made Oxford the murder capital of medieval England. Maybe, but back then it was called anatomy. You're welcome. Bye. The Alpha collaboration at CERN has reported that antimatter does not antigravitate, surprising absolutely no one except for a few headline writers who tried hard to make this result sound interesting. Okay, let me tell you why it's interesting indeed. According to the standard model of particle physics, for each type of particle there's an antiparticle. The antiparticle has the same properties as the particle, but has the opposite electric charge. When particles and antiparticles touch, they annihilate and leave behind a burst of light. That's pretty cool, but also makes it difficult to study them. Physicists are very confident that antiparticles have normal gravitational masses and don't fall up. This is because the constituents of atomic nuclei are held together both by particles and antiparticles. If antiparticles had negative gravitational mass, then atoms would have a different inertial mass than gravitational mass. The equivalence principle would be violated. We have extremely precise measurements that rule this out. Still, CERN has made a lot of effort to produce not just antiparticles, but anti-hydrogen. Normal hydrogen is a positively charged proton with an electron around it. Anti-hydrogen is a negatively charged antiproton with a positron around it. The alpha collaboration contained the antihydrogen in a tall cylindrical vacuum chamber where they held it with magnetic fields. When they reduced the strength of the magnetic fields, the antihydrogen dropped. They measured how fast it dropped, and voila, it fell just like normal hydrogen. The reaction of physicists on Twitter was mostly, do. If you're one of them, I'd like to remind you that Einstein's theory of gravity is not a quantum theory, and hydrogen atoms are very much quantum. We actually don't know how the equivalence principle works for quantum particles, and testing it for anti-hydrogen is a pretty good idea. What do you think, Albert? The US Department of Energy and Stanford University have activated the world's most powerful X-ray laser. I hope they did it by pushing a big red button. The big laser is called the Linear Coherent Light Source, LCSL for short. Its laser beam is created by electrons. The electrons are first accelerated in a straight line by SLAC's linear accelerator in California. Then strong magnets force the electrons to move on a zigzag. This makes them emit radiation, and there you have your laser beam. LCLS was the first laser in the world to produce both hard or very high energy and soft or lower energy X-rays. This has allowed researchers to use the laser for a lot of different experiments. That includes testing the quantum properties of materials and molecules, as well as understanding chemical reactions, especially at the quantum level. Understanding the buildup of molecules has a wide range of applications from medicine to agriculture. After the upgrade, the laser is 10,000 times brighter and 8,000 times faster. It's far more efficient than previously and will reach a higher resolution too. It'll be able to generate a nearly continuous X-ray beam with nearly 1 million pulses per minute. It owes its performance to a superconducting accelerator made up of 37 cryogenic modules which keep it colder than outer space. Is it just me, or is everybody dreaming of shooting with a big X-ray laser? Hello? Mr. President? Yes, dark matter is a really old idea, more than 80 years already. Oh, fresh and new idea, could just run for president, I'm sure. Mr. President? Newton said, what goes up must come down. The sun strongly disagrees. If you've ever hung out on the beach or played in a sandbox, you've probably noticed that sand tends to flow downhill when it's poured. But scientists in the US have found a way to trick sand and similar granular materials into flowing uphill instead. They did it by coating silica, that sandy stuff manufacturers put in packets to keep products dry, in iron oxide. The treated silica still flowed downward when it was poured, but then the scientists used a magnet to apply torque to the particles. This caused particles to join up with one another in temporary chains that quickly broke, resulting in an uphill motion. With enough particles of treated silica, they could even get the material to move up a mini set of stairs. This might seem like a pretty useless idea, but controlling granular material is really important in many industries, and who knows, maybe one day it'll even help us get the crumbles out of the popcorn bag. A team of chemists and bacteriologists say that life on other planets might come about entirely differently than it did on our own planet, which might much increase our chances of finding life out there. In their paper, they report looking for a certain type of autocatalytic cycles. That's a series of reactions which produce copies of the molecules that were necessary to get the reaction going. Such a reaction catalyzes itself. That's why it's called autocatalytic. It's a very basic type of reproduction, and these researchers think it's the basis for life. The team came up with no less than 270 chemical recipes that could sustain an autocatalytic reaction. Chemists can now take these combinations and test them in the lab to see what happens, and astrobiologists can use this finding to guide their hunt for life on other planets. Would you like to take part in my autocatalytic cycle? Sure makes for a killer hookup line. By the way, this video comes with a quiz on Quiz With It that'll help you remember what we talked about. Here's a little existential dread for you. A group of scientists are claiming mammals will go extinct. And for a change, it's not us who's to blame, but plate tectonics. Geologists predict that Earth's continents will converge roughly 250 million years from now to form one big supercontinent called Pangaea Ultima, though others have said it had better be called Pangaea Proxima. In the new paper, the scientists claim that the creation of this supercontinent will cause a lot of volcanic eruptions that would release massive amounts of carbon dioxide. This, they say, would warm the planet so much that mammals simply can't survive. Scientists have previously assumed that our planet would remain hospitable for life for approximately 5 or 6 billion years, after which our sun will begin to turn into a red giant and roast Earth's surface. That's quite a claim. 250 million years are a long time for species to adapt, even leaving aside that by that time we might simply be able to pump the carbon dioxide back out of the atmosphere. But the next time someone asks if I want to visit America, I'll tell them I'll wait until America comes to visit me. Thanks for listening. We'll be back next week.